Hi, I'm Estiven Martinez, and this is my AP problem number 4. So for A, two nitrogen atoms combine to form a nitrogen molecule as represented by the following equation: 2N gas produces N2 gas. So using this table of average bond energy, we need to find the enthalpy change, which is delta H, for the reaction. So we know that bond formation is exothermic, which means energy is released, and the bond that N2 formed was a triple bond because N has 3 valence electrons. The average bond energy for a triple bond of N2 is 950 kilojoules per mole. So 950 kilojoules per mole were released. So the enthalpy change, delta H, is negative 950 kilojoules per mole. For B, the reaction between nitrogen and hydrogen to form ammonia is represented below. The reaction is N2 gas plus 3H2 gas produces 2NH3 gas, and the heat of the reaction, delta H, equals negative 92.2 kilojoules. We need to predict the sign of standard entropy change, delta S, for the reaction, and justify our answers. So, the second law of thermodynamics states that if the reaction becomes less disordered, then delta S is less than 0, and if the reaction becomes more disordered, then delta S is greater than 0. The reaction N2 gas plus 3H2 gas produces 2NH3 gas has a negative sign because we started with 4 moles and ended up with 2 moles, so the reaction became less disordered. For C, the value of delta G for the reaction represented in part B is negative at low temperatures but positive at high temperatures. We need to explain why. So, we know that delta H and delta S are negative, and delta G is equal to delta H minus T delta S. At high temperatures, negative T delta S would have a high enough energy to make delta G positive when you add delta H and negative delta S. So delta G would be positive. At low temperatures, negative T delta S would not have a high enough energy to make delta G positive when you add delta H and negative T delta S, so delta G would be negative. D. When N2 and H2 are placed in a sealed container at a low temperature, no measurable amount of NH3 gas is produced. We need to explain why. So, since N2 gas and H2 gas are at low temperatures, both gases are moving too slow to collide with enough kinetic energy, so the gas particles will not reach the activation energy needed to cause a reaction and produce NH3 gas. That is why there is no measurable amount of NH3 gas produced in the sealed container.